So we are reviewing what we did last week, just because it's been like a week. So we'll go over it again, and then nothing new for homework today, just review. So what we're going to do is we need to complete the square, but to complete the square I need to kick out that 244, put it on the other side, rearrange the terms so all the x's are together, y's are together. And then when you do complete the square, you cannot complete the square if there is a number in front of that x squared other than 1. So you have to factor out that 64 before you do complete the square. If you do it in the other order, you will have it wrong. And then with the y's, I'm going to factor out that 9 first. Then from there, we're going to complete the square. So you'll do your 2 divided by 1 squared. Okay. So this one you're going to make something. Don't put zeros in the one. Okay, something like that. And then you start wrapping it. And then I'll let you just after that. All right, so we're doing, what do we do? Negative 2 divided by 1 squared. That gives me 1. But to the other side, I don't add 1. What do I add? 64 times 4, so 64. And then for the y's, we will divide 12 by 2 squared, you get 36. Multiply that by 9 to get 324 to add to the other side. Now the reason why I had to add that to the other side is because I'm putting an extra number in there. Just a reminder, we don't listen to music. We don't have headphones in, even if the music's off, during class. So the reason why I had to add those numbers over there is because I added numbers in that weren't here before. So now we're going to factor. You're going to unmultiply this. 64. That is a perfect square. And we'll add together the stuff on the other side and you get 144. So at this point, okay, now what we're going to do is we're going to set it up so it is in the standard graphing form of an ellipse. And if you forget that standard graphing form, it should be in our notes from last time, plus the day we did Desmos and graphed all that. The standard graphing form of the ellipse equals something specific, and it's not 144. It's 1. It's always 1. So I have to manipulate this equation so it says equals 1. How do I make 144 into 1? Subtract 143. Divide by 144. Yeah. So when I divide by 144, I have to divide everything by 144. When I divide by 144, I do get 1 over here. In the middle, I'm dividing by 144. This 9 and the 144 reduce to 1 over 16. So I write it as y plus 6 squared over 16. And then the first term, a little bit trickier. So when we reduce this one, it reduces to 4 over 9. But I need a number in the denominator, not in the numerator and denominator. I need it all in the denominator. So you're going to think right now, this x minus 1 is being multiplied by 4/9. I'm not going to leave this here. But right now it's being multiplied by 4/9. That's why I have a 4 on top and a 9 on the bottom. But I don't want it to multiply by a number. I want it to divide by a number. So instead of multiplying by 4/9, I can divide by what number? 9/4. You do the reciprocal. So instead of writing times by 4/9, I'm actually going to write it as divided by 9/4. And when you do that, now we have it in the standard graphing form. So we're going to start finding all the important information. One of the things it will say in the assignment, which it said this last time as well, eccentricity. You do not need to find that eccentricity. Okay. But we'll find everything else. What do we start with? What do we find first? Center. Let's find the center. So what I'm going to do is we're going to multiply all of this out, simplify this whole thing, so it looks like the original question. Okay. This is really touchy today, and I don't know why. So where's our center, which is HK? Where's our center? Is it negative 1 or is that positive 1? Is that positive 1, comma, negative 6? Good. And you guys have a graph, which I got to put mine on there. I don't know where my graph went. After we do our center, then we'll do our major and our minor vertices. So I'll start with major. So major vertices, am I going to use 9/4 or 16? 9/4 or 16? How do I know which one to use? The bigger one. This should be like logical stuff. Like if I'm doing a major vertice, we're doing the bigger number. And how do I know if it goes with the x's or if it goes with the y's? How do I know that 16 is going to be, or the major vertice? How do I know that's going to be vertical? I'm asking for like really common sense logical answers here. Right, it's right under the y, so it's going to go up and down. So we're going to have, you do have to square root it, plus minus 4, and that is going to be added and subtracted from the y value. So we will have 1 negative 10 and 1 negative 2. And I'm sorry, I don't know why this thing keeps graphing extra things or plotting. This thing is super touchy today. I can't figure out why. Maybe it needs to be charged. Okay, so that means for the minor vertices, we're going to square root the other value and put that with the x's. That's better. It's probably what it was. So we're going to square root 9/4. That's going to give me plus minus 3/2. And I'm going to add or subtract that to the x's for my minor. So I will have negative 1/2, negative 6, and then I will have 5/2, negative 6. Okay, the next thing that I'm going to show you, I have not shown you yet. So the next thing that we're going to do is to help you draw it and to help you do what we're doing tomorrow. The outline of the major and minor vertices, I'm going to draw this imaginary rectangle. It's not really there, but it's going to help it. Come on. I'm going to draw this imaginary rectangle. It's not really there, but it is going to help us draw our ellipse, and it's going to help us in tomorrow's lesson when we do hyperbola, which are related to ellipse. So once I draw that, when I go to make my ellipse, I just need to make sure in those corners, it's kind of rounded out towards those corners. Rounded out towards those corners. Don't make it look like a football. Go out towards those corners more. That box will help you do that. That imaginary box that's not really there. And then tomorrow, that imaginary box will be even more important. And then when I draw a circle, I think about the imaginary square. I do the same thing. Make sure it's rounded out towards the square corners. All right, then we finally have the foci. And the foci, we had a formula, which you can use the formula. Does anybody remember the formula?
That's the big one, that's the small one.
See, that's how I remember it. But the formula is like a squared minus b squared equals c squared. Okay, but I know the answer has to be positive because I have to square root it. So I take the big one minus the small one. And what are we talking about? Big what and small what? So you're looking at the original denominators. We're not looking at the square rooted denominators. We're looking at the original denominators, the 16 and the 9/4. So we're going to subtract big one minus small one, and then square root that answer. And that'll give us our foci, the translate for the foci. So I'll have square root of 16, take away 9/4. Common denominator, we get square root of 64 over 4 minus 9/4, which equals square root of 55/4, which equals square root 55 over 2. Square root. And then we write our foci. The foci we know go on the major axis, so it's going to go from the center to the y values. Square root of 55 over 2 to the y values. So my foci will be 1, comma, negative 6 plus square root 55 over 2, and 1, comma, negative 6 minus square root 55 over 2. But to graph that, I'm just going to type in square root of 55 over 2 and get approximately 3.7. To graph that, I'll just go from the center up and down 3.7. As accurately as I can. So that's just a review of what we did, and you'll do like 4 of those in your assignment. Some of the other questions in the assignment are going to give you information like, this is the foci, find the original question. So you're going to kind of like be working backwards on some of them, just like we did last week. There's one more example I want to do together, because if you can do it backwards, then you really get it. So what we're going to do is, on that next example, and I'm going to do one up here, on that next example, that last example we're going to do today, you're going to make up your own. So I'm going to make up my own real fast, but you make up your own, do not copy mine, okay? So I made up my own graphable ellipse. That's the graphing 4. Go ahead and make up your own. Don't copy my numbers. Do not make the center at 0, 0. Actually, give it numbers. Give it numbers. Where's that example you were doing? There's some other stuff there. So what you're going to do is you're going to take this equation and you're going to multiply everything else, simplify this side, so it looks like that. Okay? All right, does everybody have one? All you're doing is making it up. You're not doing anything else with it yet. Well, if you multiply this by a number, you got to multiply this also by and the other side. You're going to multiply one side by about that. So you're kind of on the right track. All right, so what we're going to do, and I'll get you started, is I'm going to take this equation. You're going to take this equation, your own, and you're going to multiply everything out, and you're going to simplify it so that it looks like the very original one that I gave you for the first example, where it says, you know, something x squared, something y squared, something x, something y plus a number equals 0. So you're going to basically go backwards of how we put it into the graphing form. So I'll go through the first part with you, and then you just need to really try it, and then I have a way to check your answer as well. So when I look at this, the very last thing that we did on this example, the very last thing that we did was what? We divided everything by 144. So the very first thing you're going to do is multiply everything by some number. But what you want to multiply by is you want to multiply by something that will cancel out your fractions, cancel out your denominators. So when you look at my example, I have a fraction of the denominator of 9, I have a denominator of 100. What number do 9 and 100 go into? 900. So if I multiply, come on. If I multiply both sides of the equation by 900 over 1. If I multiply everything by 900 over 1. That means over here on this side, I'm actually distributing that 900 to both terms. What happens to my 900 over my 9 right here? Anything special? What happens? Then what happens here? 900 over 9. What's my goal? I'm trying to do what? What? What's my goal? Katie, what am I trying to do? It would equal 100. Over what number? Over 1. My goal was to do what? Get rid of the denominators. Okay? That was my number one goal. So I would have 100 multiplied by x plus 4 squared plus what happens over here? What's 900 over 100 turn into? 9. Multiplied by y minus 10 squared. What happens on this side? It becomes 900. So when I multiplied everything by 900, I don't have any more fractions. Yay, no more fractions. Then you think order of operations. You're trying to simplify this. What is my next step? If I'm doing order of operations and I want to simplify, what is my next step? Distribute what? You got really quiet. Distribute what? Number. What number? Order of operations. First thing is inside the parentheses. I can't do x is 4 because I don't know what x is. What's my next thing of order of operations? Parentheses and exponents. Are there any exponents I can take care of? Yeah, so I need to square x plus 4, and I need to square y minus 10. So that's what you were saying. Write it x plus 4 times x plus 4. And y minus 10 times y minus 10. Multiply that out. So we're just totally working backwards of what we did before. So now I've multiplied it out. After we multiply it out, then what do? I'm going to get rid of the parentheses after I multiply it out. What should I do? Yeah, I need to distribute in that 100. I need to distribute in that 9. And then finally, I need to make that say equals 0 and combine a few like terms over here. So I'm going to reorder it so it looks like the original. And I end up with my standard form. So what you're going to do if you haven't already started working on your own is you're going to multiply out your own, just like I multiplied out my own. And then we're going to use Desmos to check it. So after you've multiplied it out in Desmos, you're going to type in the original question that you came up with, and then your multiplied out answer to see if they're exactly the same graph. So you get Desmos, and if you don't, you've got computer. Desmos.com. If you're doing it on your phone, make sure that's the only thing you are doing on your phone. So you're going to go to Desmos.com. Oh, just yeah. Did you get all multiplied out? Okay, so go on Desmos. So you're going to type both of those in to see if they're exactly the same. So if you've multiplied it all out, make sure there's an equal sign on your paper. It should say equal 0 when you're done. You can't just get rid of that equal sign. After you multiply it all out, you're going to go on Desmos, type in the original, and type in the new one to see that they completely are the same graph. If they're not, that's going to tell you to sling mistake somewhere. And if you need to grab a computer, I got the card. Like if your phone's really teeny tiny and you don't want to use it, or you're low on battery, or you can bring it, whatever the reason may be, you can use the computer if you like. I added together, oh, I did it wrong. It should be 1,600. I just didn't look at my handwriting correctly. All right, so you've done something wrong. So I have the steps up there. If they match up, then you know you've done it correctly. If they don't match up, find your mistake. Desmos.com? Should just be like start graph. We are going to do a Desmos project coming up. So something's wrong. Well, I don't see the step where you have this. Is that in your head somewhere?
Yeah.
That possibly could be where your mistake is, but I can't see it, so I don't know.
Okay.
So put that step on your paper before you distribute those numbers through. Did yours match up? Okay. Just for your month, you can work on it. It's written over there. Yours match up? Oh, you're not. Sorry. No, those do not match up at all. So what happened? If you have all your steps, I can work through it with you. If you don't have all your steps, it's going to be hard for your help. Okay, so let's see if this, I don't know if this is the same. 144 plus 200 is 344. Oh, I lied. That's 544. Oh no, the number. Sorry. Now are they the same? Yeah, that one you just multiply, remember? Yeah. And then you multiply it by 100. Equal up? Does it match? Good. Does it match? You got both of them grab there? No, you don't. Good, grab that one for your second one. Business? You grab these two? Okay, insert your second. It's written right there. So if you're having trouble, because, yeah, if you make one silly little mistake or you type it in wrong, it's not going to work. Yeah, I was about to say it doesn't look like a circle. Still not right. Where's your other? You like move that thing right there. That might be the only mistake. So then that's going to change what numbers. See if that's the only mistake. So figure 7, you've got 4 graphs, which I give you graphing report, and then you're writing the equation with information. Should pause this video to listen to me.